Good morning, students. Let us proceed force and laws of motion. Today we will discuss Newton's first law of motion. Newton's first law of motion states that an object continues to be in state of rest or in state of uniform motion unless unbalanced force acts upon it. See here, this is an object. It is at rest. It will continue to be at rest unless any unbalanced force is applied on it. This is an object and suppose it is moving. It will try to be in motion unless an unbalanced force acts upon it. So which is unbalanced force in this? The frictional force which is acting on this. So it changes its state. From Newton's first law we will get two things. First thing, an object tried to be in rest, and another, an object tried to be in motion. From these two things we are getting, first is that if object is at rest, the new word you will get inertia. So from Newton's first law gives an idea of inertia. Inertia has derived from a Latin word inert. Inert means internal property. Inertia, how we define it? The internal property of the body to resist the change applied on it, either it is state of rest or it is in state of motion, uniform motion in straight line. So see here, this is an object. I am applying force in this, but it is not moving. It is not moving, that means it is opposing my force. When my force is greater than its resistive force, then only it will move. Inertia is very much desirable or helpful to us. Very simply, you see, all the things, book, pen, marble, I am keeping on the table. Weight of the book is acting downwards and table inertia means it is opposing force is acting upwards, and see it is not falling. I am sitting on the chair. Chair is at rest. It will try to remain at rest. When I sit over the chair, I am applying force on this, but the chair is also applying opposite force, that is resistive force, that is inertia, makes me sit on the chair. So it is very helpful. Sometimes what happens, it is not desired. Take two objects. This object of this mass is 20 gram and object of this mass is 10 gram. Now you see, naturally the object whose mass is less, we have to apply less force and makes the body move. Object whose mass is more, we have to apply more force to overcome the resistive force of this object. Mass is measure of inertia. If mass will be more force is applied, required to move the body. If mass will be less force is required to move the body. This inertia is of three types. Inertia of rest, inertia of motion, inertia of direction. Today I will discuss with you inertia of rest. Inertia of rest means an object will try to remain at rest until an external force or unbalanced force is applied on it. Very simple example, we play carom. Now in this period, lockdown period, you play carom. Carom piles we are keeping one above the other, and from the striker we hit it. As we hit it, the piles which is at the surface of the carom will comes out and rest of the piles remain same. Means all the piles are in state of rest. The lower piles, it will try to remain at rest, but as we hit it, unbalanced force is applied and it comes out. Rest pile will remain at rest. You take a coin on a small piece of cardboard. Take a glass and keep that cardboard on this. Hit the cardboard. When you hit the cardboard, coin will fall inside the glass and cardboard fly off. So coin was at rest, it will try to be at rest, and as cardboard fly off, it will enter inside the glass. You have very common experience as we are sitting in bus or train and that is at rest. Now you see here, suppose this is a bus and we are sitting on it. As soon as the bus starts moving, our lower portion is in contact with this. That means it will try to remain at rest, but as it is moving, it will move, but our upper part of the body will try to remain at rest and we fall backward when vehicle starts. Next you see what happens. That is Newton's first law. We take a carpet and suppose this is a carpet. You beat this carpet. Now this is carpet or doormat. We have to clean it. Doormat is at state of rest. Dust particles are also at state of rest. When we beat this carpet, then doormat is moving, but dust particle will try to remain at rest and it is not getting any surface, it will fall down. So like this, we are cleaning or dusting the doormat or carpet. Next you come, suppose this is a tree and fruits is hanging in this tree. When you shake the branch of the tree, force is applied on this branch, but fruit will try to remain at rest, and then what happens? This fruit will fall when branch is shaken. So the body which is at rest will try to remain at rest. Last example I am saying you, when you fire a bullet, suppose this is a window pane, when you fire a bullet, the bullet will hit the glass pane. With that area only, it will take out the glass and rest of the pane will remain like that. Means glass pane is at rest. When bullet hit it, its large velocity take out that area of the glass pane, makes the hole, and rest of the part will remain same. But if you will throw a stone on the glass pane, you have seen it get cracked. Why it get cracked? Whenever we throw stone on it, the velocity of the stone, it takes some time, it hits the pane, and that velocity, that force will get all over on the pane, scattered on this pane, and this pane will get cracked. But very high velocity of the bullet will take out or makes the hole in the pane of that area. So this is the application of Newton's first law.